Hello students, welcome to your second video on arithmetic series. Today we're going to focus on the learning target. I can find the sum of an arithmetic series using summation notation. And summation notation can also be called sigma notation. Summation notation or sigma notation is just a fancy way to indicate that we are finding the sum of an arithmetic series. So let's start looking at what sigma or summation notation looks like. So what is sigma notation or what is summation notation? This is it. This is an example. What we see here is a Greek letter sigma, that is the Greek letter sigma, with some lower limit and some upper limit. So what I want you to make a note of here is that this number at the bottom is your lower limit, and the number at the top of the sigma is the upper limit. So this is just the basic way that we write the sigma notation with a lower limit and an upper limit. And this portion that is over here to the right of the sigma is where we're going to write our explicit formula that describes our sequence or our series. This particular explicit formula is not linear. That's not linear, which tells me that this would not be arithmetic. And that is simply because there's a higher power than 1 in it. So this is not from an arithmetic series. The examples we will do in this lesson will be from an arithmetic series. So you'll see a linear term here where the highest exponent will only be 1. So again, our parts include our lower limit, our upper limit, and an explicit formula to describe the series. Okay, so here is one of our examples. Find the sum of the finite series. So in order to find the sum of an arithmetic series using the summation notation, our lower limit gets substituted into the explicit formula to find the first term. So to find A1, we substitute 3 into our explicit formula in place of the variable. So I know that 2 times 3 is 6, and 6 plus 5 is 11. So in this series, A1 is 11. Then we're also going to need to find AN. AN is going to be found by taking our upper limit and substituting that into our explicit formula in place of K. So we'll find that by saying 2 times 7 plus 5. So 2 times 7 is 14, and 14 plus 5 is 19. So I know then that AN is 19. Now, in order to find the sum of a series in the way that we have learned, we use this formula. Sn equals n over 2 times A1 plus AN. So we really only need to know 3 different parts. We need to know A1, which we have found. We need to know AN, which we have found. And we need to know what n is in order to evaluate this with our formula. So in order to find n, what we will do is take our upper limit, this is how we find n, take our upper limit of 7, and we subtract our lower limit of 3. But then you have to add 1, because this is like finding the term where we substitute in 3, 4, 5, 6, and 7. So we're substituting in 3, 4, 5, 6, and 7, which is a total of 5 numbers. So I can count that out, and I know that n is finding 5 numbers. But if I do the subtraction, 7 minus 3 is 4. And the reason that's off by 1 is because it's like not counting this first number. So here's how finding n is going to work. Let me erase this and write it a little bit more descriptively. We will say upper limit minus lower limit plus 1, because we want to be sure that we count the first term. So 7 minus 3 is 4, and 4 plus 1 is 5. And yes, if we go from 3 to 7, 3, 4, 5, 6, 7 is 5 numbers. So n is 5. So now I'm ready. Now that I know that n is 5, I'm ready to substitute all of those numbers into my formula and find the sum. So this is the sum then of 5 numbers, where n is 5, and a1 is 11, and an is 19. So 5 divided by 2 is 2.5, and 11 plus 19, let's see, that's 30, and then 2.5 multiplied by 30 is 75. So the sum then of those 5 numbers would be 75. So the sum of that series is 75. Now you may say that that seems like a lot of work. Step 1, we had to find a1. Step 2, we had to find an, and we found a1 and an by using this explicit formula. Step 3, we had to find n. So we had to find all 3 numbers, and then we had to substitute all 3 of those numbers that we found into our arithmetic series formula and evaluate that. It's not a lot of hard work, but yes, it is a lot of work. It is a lot of a long procedure. So would you like to know a way to do this a little faster? I thought you might. Your calculator actually can help you to do this. And I do not have my calculator projected here for the video, but if Miss Moon will show you this in class live on the board. But on the video, I will just try to talk you through the buttons to push, okay? So on your calculator, go ahead and clear the RAM, second plus 712. After your RAM is cleared, I want to show you how you can find the summation notation button, if you will, on this calculator. Now, it's in 2 places. One place that you can find it, just write it down here, is under Math. So if you will push the Math button and then scroll through the list until you see where it says Summation. It's choice 0. And it's got the Greek sigma there. Okay? So you can choose that by hitting Enter. And then it gives you a Greek, oops, sorry about that. Just undo that. It gives you a Greek sigma, and it gives you some blanks to fill in, like a template. So it gives you a first blank. Every time in this first blank, you need to use the variable x. No matter what variable it gives you on your paper for the problem, you're going to have to use an x for the calculator to understand what you're doing. So you're always going to begin with an x. Then it says equals, and then there's another box. It pops over to the other box. In the other box, you're just going to type your lower limit, which was 3. So we type a 3 here. Then, if you'll up arrow, it'll take you up to the box on the top. And there we're going to type our upper limit, which in this problem was 7. Then right arrow, and you should see some parentheses with a box inside. And inside those parentheses, you're going to need to type the explicit formula, which in this case was 2k plus 5. Well, again, your calculator is not going to understand if you use the variable k. When you're inputting this into the calculator, you're going to need to use x every time. So you're going to type 2x plus 5 inside the parentheses that were already given. Then hit enter, and you should get the sum of that series. What do you think about that? You think that procedure might be a little faster than step 1, find A1, step 2, find AN, step 3, find N, and then substitute in the formula to get 75. I mean, that was a lot of work that your calculator can do in just a few punches of a button. And I would be crazy not to share this information with you. Okay, I told you there's 2 places to find summation on your calculator. So we're going to take a look at this next example. And I'm going to show you the second place that we can find summation on the calculator. The first place we found it was under math. The second place we can find it is in your shortcut menus. If you will tap alpha and then choose window. Window is the second button on the top row. Alpha window, and then choice number 2 has got this Greek sigma. I feel like that might be a faster way to get it. If you like that, then use that. If you like looking under math, then use math. There's 2 right ways to get this on your screen. But then we're going to just type in what we see. Please notice here that the variable uses t. And the only caution I can give you is that if you type this in with the variable t on your calculator, you're going to get wrong answers. You're going to have to use x's, because your calculator is going to store t as some number, not just as an unknown. So you're going to need to use x's when you put this in the calculator. So if we'll type this in exactly the way we see it, we've got this Greek sigma. We're going to put an x in the first box. It's going to hop over, and we're going to put a 2 in the second box. We're going to up arrow, and we're going to put a 35 in that top box, which means we're adding, let's see, what is 35 minus 2? That's 33 plus 1. We're adding up 34 numbers here. 34 numbers described by the explicit formula. They've already got parentheses. You're going to input 4x minus 17 into those parentheses. And the sum of this series equals 1938. The next example, I'm going to take a moment and let you guys try on your own and pause the video. While it's paused, take a moment to answer it, and then we'll see if you got it right. So if you got 3,649, you got this right. Congratulations, you've mastered summation notation or sigma notation with your calculator. Please remember, if you missed it, maybe your mistake was that you have to use the variable x when typing this in the calculator. If you missed it another way, you've got a typo somewhere. Okay, the next question is asking me to take a series and write it in summation notation. Now, I kind of told you already about the parts of summation notation. We start with, we're going to say 1, and we're going to go up to, this is going to be A1, we're going to go up to however many terms this is. N is going to go here. N is going to go right here. Okay, so let me go back and erase that. I should have used X here because we are always using X there. Okay, sorry about that. And we're going to go up to however many terms we have in our series. Secondly, beside of this, we're going to put our explicit formula in parentheses. So we're going to have to do a little bit of work here. We're going to start with AN equals A1 plus N minus 1 times D. The formula from arithmetic sequences that we should be very familiar with. We're going to substitute the values that we already know. 207 is AN, so substitute 207 here. A1 is our first term, that is 7. We do not know N, that's what we are trying to find. And our common difference is, what am I adding to get from 7 to 11? That's adding 4. 11 to 15, adding 4. So our common difference is 4. So we will backwards distribute here. Bring down this 207 equals 7 plus 4 times n is 4n. 4 times negative 1 is negative 4. And then let's bring this 4n down and combine the like terms 7 minus 4 to get positive 3 is equal to 207. Now when you get to this step where you've got something n plus something or something n minus something, that is the explicit formula. So I'm going to take a moment and put that back here. 4n plus 3 is my explicit formula. And then to find out what n equals, I'm going to take this explicit formula equal to 207, and I'm just going to continue solving for n. So I'm subtracting 3 from both sides. I ended up with an extra line here. Subtract 3 from both sides, and that cancels. That leaves me with 4n is equal to 204. Then dividing both sides by 4, I get that n is equal to 51. So if n is equal to 51, that's the last thing I needed for my summation notation. I'm adding from the first to the 51st term the arithmetic series described with the explicit formula for n plus 3. We're going to do this one more time. We're going to write a summation notation. We're going to start with x equals 1 to n, and we're going to find an explicit formula for the series. We're going to start with our an formula, a1 plus n minus 1 times c. An, we know, is 268. Substitute that in. A1, we know, is negative 5. Substitute that in. We do not know n, but we can find our common difference. If we just do some subtraction here, 16 minus 9 is exactly 7, so the common difference is 7. Backwards distribute, 268 equals negative 5 plus 7n minus 7. Then we're going to bring our 7n down and combine like terms negative 5 minus 7 to be negative 12 equal to 268. Pause, because this is my explicit formula. 7n minus 12 is the explicit formula. After you find that explicit formula, we'll continue solving by adding 12 to both sides. So 268 plus 12 gives us 280. And then divide by 7. So n equals 40. So our top number here in our summation notation is 40. I hope this has helped you, that this video has helped you to understand how summation notation works, that you can use summation notation on the calculator, you understand what it represents and how you can create it. Good luck on your assignments.